Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques. And as I promised you that we are going to be looking at the frequency polygons, having finished the histogram. So today we are going to look at frequency polygon as one of the curves or charts that can be used to present data. So we are looking at frequency polygons. Of course, a frequency polygon refers to the graph. This is a graph. This is a graph joining of the midpoints, of the tops of the adjoining bars. So the frequency polygon, of course, is just a graph that displays the data by using what we call lines that connects points plotted for the frequency, for the different frequencies at the midpoints of each of the classes. So they are basically graphs that displays the data by using lines. We use lines that connects points plotted for the frequencies at the different midpoints of the different classes. So the frequencies are represented by the heights of the points, or of these midpoints that we have. So the midpoints of let's say the first and then the last classes are going to be joined to the midpoints of the classes preceding the first and succeeding the last classes respectively. Of course, and this is going to be at a zero frequency to complete the polygon, meaning that when we are drawing these lines, when we are drawing these polygons, we always use lines, but these lines, they have to connect to the horizontal axis so that they can be able to complete. You don't just draw it as if you are drawing a line graph. What differentiates this from a line graph is the fact that this is supposed to touch the horizontal axis to complete a frequency polygon, or to complete a polygon. So the midpoints of the first and then the last classes are joined to the midpoints of the preceding classes, those that are preceding the first and those that are succeeding the last classes respectively. To, of course, when you connect the first and then the last, it is always going to be at a zero frequency because we are connecting to the horizontal axis. And remember, we said when you are drawing our graphs, we always draw these graphs with a scale starting from zero. That's why we are saying it will be at a zero frequency for us to be able to complete the frequency polygon. So what we are saying is that, first of all, we have talked about midpoints. It means we are plotting midpoints against the frequencies. So one thing that we need to be very careful with this is that we have to do some computation by computing the midpoints and then getting the frequencies. Now, of course, when we are getting the midpoints, we know that when we want to find the midpoints of each class, there are two options. We use two options depending on what we have. We know that we talked about how to find these midpoints when we are introducing this topic, and we say that for you to find the midpoint of each of the class, we said that we add the upper and then the lower class boundaries, then we divide by 2. Of course, there are situations where we are going to be just dividing. We add the class limits instead of using the class boundary. So we shall look at those different scenarios. But what you have to understand is that we get midpoints, and we said for us to get the midpoints, we get the lower class boundary and then the upper class boundary. We add them, then we divide the answer by 2. It's like we are just getting the average points. So for us to get the midpoints, we've said we look at the lower class boundary. So it depends on what has been given to you in the question. So for the midpoints, we said we get the lower plus the upper, then we divide by 2. But these can be class boundaries or they can be class limits. So it depends on what has been given to you in the question. But either way, we get the midpoints. That's how we get the midpoints. So once you have computed those midpoints, then you can be able to get the frequencies. Of course, the frequencies will be given to you. Now, the next thing that you do is for us to draw. Of course, these are the steps that we go through to complete the frequency polygon. Once you have done with that, you draw the x-axis, the x and y axes. Of course, when you draw this, you label the x-axis. The x-axis is always going to have, the x-axis is going to be labeled with the midpoints. The x-axis is going to be labeled with the midpoints, and then the y-axis is going to be labeled with the frequency, or the frequencies. So the midpoints of each of the classes is going to be represented on the horizontal axis, and then we use the suitable scale, because we need to get a scale that we can be able to interpret, and then we know what we are plotting. So remember, when you are plotting for any of the coordinates that we are plotting, we always plot the x and then the y. That's why we are saying this is the x-axis, this is the y-axis. So what is on the x-axis are the midpoints, and what's on the y-axis are the frequencies. So what we are going to do, we shall have a midpoint. Let's assume it is 100, then with a frequency of, let's say, 3. We plot like that. You first look at the x-axis, then you plot. You pick 100, then you go on the y-axis, then you pick a 3. So once you have drawn the x-axis, you have labeled the x-axis as the midpoints, and then you have labeled the y-axis as the frequency, then the next step, of course, to go on with is for us to be able to plot. We plot the we plot the midpoints, its midpoints against, we are plotting, actually we plot the midpoints and we plot midpoints and the frequencies. Sometimes these midpoints are called class marks. Sometimes they are called class marks. So we plot the midpoints and the frequencies. So if we are plotting, we are starting with, let's say, 100 to 3. It means its frequency against what? How these pairs are ordered. It will be frequency against the midpoints, depending on how this has been arranged, because we start with this, we start with the midpoint. So we plot frequency against a given class mark or midpoint. And of course, once we are done with plotting the midpoints and the frequencies, then the next thing that we are going to go through is for us to be able to connect the adjacent points with a line segment. The next one is for us to connect the adjacent points, connect the adjacent points with line segments, So what we do, we draw a line, and I told you this line is going to be drawn connecting the adjacent points, but at the same time we draw the line back to the x-axis, and that is at the beginning and then the end point of the graph. When we are looking at when you are following at the same distance that the previous and then the next midpoints would be located. So that's why we said we draw these points and they are going to have a 0 frequency. The other thing that you need to understand from this is that the frequency polygon and the histogram, of course, there are two different ways of how you can present a given data set. But the choice of whether someone is going to use a histogram or is going to use a frequency polygon depends on what the researcher wants to find out. Because I told you that some statistical softwares, when they are drawing their frequency distribution, they always use the frequency histograms, and then the polygons, they always take the midpoints. So it is from that aspect that we can use any, as long as we are able to know what we want. But of course, there are some aspects whereby the frequency polygon is going to be preferred. The frequency polygon can always be used in places of course, in particular circumstances where we have very many classes in the distribution, or where we have two or more frequency distributions that we need to compare, or that we need to be compared. So of course, once you have joined these points, that's it, and that's how the frequency polygon will look like. So we need to look at a simulation, and maybe you can be able to find the different aspects that we are looking for. Maybe we can use one of the previous examples, that like the one we used last time. So we have examples. Let's say the weights of 65 children are given by the following table. Let's have the table looking at the weights. Maybe it is 50 to 60, 60 to 70, 70 to 80, 80 to 90. And then of course we provide also the frequencies, or the frequency. Of course, the first one is 8, second one is 10, third one is 16, and this is 14. So move downwards. Of course, the next one is 90 to 100, 100 to 110, then 110 to 120. This one has 10, this is 5, and this is 2. Of course, the required is for us to draw a frequency polygon. Frequency polygon. Draw a frequency polygon. So of course we start with the steps. Of course, the steps for us to draw a frequency polygon without drawing a histogram, we look at this. There are two aspects. Of course, you can draw, it is very possible for you to draw a histogram, and at the same time you draw a frequency polygon within the same graph. It is possible. Of course, the first step, our step 1, is for us to find the midpoints. Find the midpoints, or the class mark. The class mark of the different classes. Midpoints of the different classes. Then of course the second step is for us, when we have gotten those, for us to just draw the perpendicular line, the two perpendicular lines. Perpendicular lines to represent the class mark, or the midpoints, the class mark on the horizontal, and then frequency on the vertical. And of course the last point is for us to plot the ordered pairs. Of course, we draw frequency against the class max. The last point is for us to plot the ordered pairs of the frequency against class max. So let's get to solve this. So let's indicate what we have and then we solve this. So we have the weights, then we go to the frequency, then we need the midpoint, so what we call class max. So this was a 50 to 60, a 60 to 70, 70 to 80, then 80 to 90, 90 to 100, 100 to 110. Of course, the frequency that was given to us, this was 8, this is 10, this is 16, 14, 10, 5. Of course, we are left with one class. So we can first get the midpoints. We say that for us to get the midpoints, we add. These are exclusive classes, meaning the class boundaries are the same as the class limits. So these can be class limits or class boundaries. It will be 50 plus 60 divided by 2 for the first class, this first one. This will be 110 divided by 2, that gives you 55. So the 55 will be here. Then we do the same to the second class, 60 plus 70 divided by 2. Now, the other option that you can use, you can now get the class interval. You know what is the class interval? From 50, to get the class interval, remember we said to get the class interval, you pick either this side and you subtract, or this side and you subtract. You'll find that it's 10. So it will be, for the next class, it will be 55 plus 10. That will give you a 65. Or you add your 60 plus 70 divided by 2. 60 plus 70, that will give you 130 divided by 2, that is 65. So either way, you will be right. This is 65 plus 10, 75 plus 10, 85 plus 10, 95 plus 10, it will be 105, 105. Then of course we look at the last class. That the last class was from 110 to 120. But this method, if you are to use this of adding the class interval, you make sure that the class interval are uniform. Sometimes the class intervals may not be the same. So if they are not the same and you use this method, you'll get a wrong answer. So you have to be extra careful when you are getting those values. So this last one was 110 to 120 with a frequency of 2. And then when you add 110 plus 120 divided by 2, it gives you 115. Of course, now that we know the points that we are going to plot, we take the class class mark and because this will be on the x-axis, this is on the y-axis. So we take this first, then we record this. So the points or the coordinates that we are going to plot are going to be 55 and 8, comma 65 and 10, comma 75 and 16. That's the frequency for that class. Then 85 and 14, 95 and 10, then 105 and 5, and 115 with a 2. So in the exam, you don't need to give these points. I'm just bringing out these points to show that what you are seeing here as first is the class midpoints, then what comes last is the frequency. That's why we are saying we plot frequency against what is to be against is has to be on the horizontal axis. So we go ahead and then we create our scale, then we'll be able to plot, and then we join the points. Of course, if you look at the figures that we have on the x-axis, that is the horizontal scale. So we get our horizontal scale, and we've seen that the highest value on the x-axis is 115. So we can use maybe 1 centimeter to represent 20 units. So that one small square is equivalent to 20 out of 5. That would be 4 units. Then the vertical scale we can use, because we have seen that our highest frequency is actually 16. So we can use 2 centimeters to represent can use 2 centimeters to represent 1 unit or 2. Let's just take 2 units. So that one small square will be equivalent to 2 out of 10. That will be 0.2 units. So you need to be able to interpret the scale that you have used. It is very important because we will be plotting these values that are not going to be absolute like the way you have named based on your scale. That whatever number that you have, you are going to plot it direct. Other figures, you will have to compute the small squares to be able to compute or to be able to plot their values. So let's draw those 2 perpendicular lines, and we said we start from 0. And the other difference between a frequency polygon and a histogram, here we don't have that kink. The kink is not going to be there. So on every graph that we draw, make sure you get you get to identify the differentiating features between those that we have given. Of course, this side we have frequencies, but me, I'm just going to label any. We start from 0. Maybe I can call this is 2. Let me call this 2. Then this is 6. This is 8. This is 10. Let me call this 14, and this is 16. Then we come and label our values depending on the scale that you have. Here we have midpoints or class mark. You name those axes, and then you also put a title. You can just say frequency polygon. Of course, this side we are saying you base on the scale that you have, but we have 7 items to plot. So you can put, maybe this is 55, maybe this is 65, you can say this is maybe 75, this is 85, then this 95, can put this to be 105, this can be 115. Then we start plotting. Of course, the first one we plot 55 with the coordinates that we had to plot, 55 with 8. So I move 55 with 8, it's around here. We put a point, then we do a circle. Make sure when you are drawing this, neatness is needed. Then 65 with a 10, 65 with a 10. Then we also draw 75 with a 16. Then we also go ahead to draw 85 with a 14, 85 with a 14, 85 with a 14, it's there. Then we also have 95, 95 with 10, 95 with 10. Then 105 with 5, and then 115 with a 2. 105 with a 5. Let's assume the 5 is around here. And then this one of 115 with a 2. It's around here. So we connect these values using a ruler so that we can have straight lines. These are just lines, they are not curves. This is not a curve, it's a line. Then you connect, we said you connect from where it came from. You connect to the horizontal axis. You don't connect like this, no. You connect in the way it is flowing. If it is flowing like this, then that's how you connect. Even this side you connect like that. In the shape it is taking, so you follow the shape, not just using straight line just to connect from where you have plotted the first plot. You just connect depending on how it is flowing. And of course you will see that that's how the frequency, how the frequency polygon is drawn. It's also an examinable number. Of course, most of these things are examinable that we've started on, even the theoretical aspects. So it depends on the examiner where they want to pick whatever they want to set. But we have to make sure that we get everything out. So what we are left with as far as chapter 5 is concerned are what we call the curves. We are left with curves alone. We are left with curves. And of course, I want us to look at curves as our next item. Of course, we are going to look at only 2. We are going to focus on only 2. We have what we call the ogive, or sometimes they call them the cumulative frequency cumulative frequency curve, cumulative frequency curves. And then the other one is what we call the Lorenz curve. The Lorenz curve or curves. Those are the two that we are going to focus on. And once we are done with these two, then we shall conclude this chapter 5. So once we are done with the curves, we will be done with chapter 5. And we shall move to chapter 6, which is the measure of dispersion or measure of central tendency.